our meetup. Harsha, it's great to have you. Let's talk about OpenMetadata 1.10.
All right. Thanks, Nick. Antoine, that was an awesome presentation. Now, let me go back a little bit. It feels like yesterday we released 1.9 and 1.10 coming along. Wednesday next week, September 30th is the release date, so we're excited about it. Not going to touch the entire feature list. It's humongous, but we're going to talk about a few important things. Now, I'm going to take all the way back to where we started, right? So what is open metadata? What schema first means? When we started open metadata, we noticed there are no standardizations around metadata itself. Like if you have using an existing catalog at that time, there used to be key value pairs. There used to be very proprietary schemas. There is no open source, open specifications for metadata. That was our motivation to start open metadata to start off. We need to solve the problem. So we came up with JSON schema, standardized vocabulary around metadata. What is standardized vocabulary? How do you define a table in an organization? What should table contain? Table should contain a name. Maybe it should contain a description. Maybe it should contain a columns. How do you structure it so that across the organizations, they're not reimagining how to model the metadata? So that's what we brought as the first step towards, as a foundational steps towards making metadata available in an organization. So we built extensive JSON schemas. On top of my head, I think there are around 400 schemas to manage your metadata in a standardized format. All of these are published, available in open source for anyone to look at. Now, what did this give us? This gave us a standardized vocabulary that can be changed from company A to company B. The table definition remains the same. From within the company's teams, how do you model your metadata remains the same. And on top of that, we built APIs. These APIs are actually generated out of JSON schemas in itself. That's the power of JSON schema. So what we do is standardize the schemas. That JSON schema becomes our server-side API code. Same schemas generates our Python code, which is your connectors, and even including the open metadata UI, all the fancy UI that you see generated through the JSON schema. So one schema to rule them all, right? That's a great start. So we build APIs, extensive, very well documented. I think Nancy was showing earlier about the documentation. Even that documentation is coming from JSON schema itself. So this is the power of open metadata, power of JSON schema. So now, since we have the REST APIs, we built all of our connectors using this JSON schemas. So that's one of the reasons we're able to ship almost 100 unique connectors to cover that across your data infrastructure. But we all know metadata not going to sit in one of those 100 data services that you may have. People use files. People use other mechanisms to store maybe a proprietary infrastructure. They want to bring their metadata into open metadata. How would they do it? So initially, we have open metadata APIs that we all use. We gave that REST APIs. That's great, very well documented REST APIs. Then, hey, community comes and asks, hey, it would be easy for me to, if you can provide an SDK. So we use the same JSON schema and open APIs to generate SDKs in Java as well as in Python. These are all great. Has been a lot of use from our community, which is, we get a lot of questions and queries around that APIs. We thought, hey, but these SDKs are also close to how the REST APIs operate. For example, I want to update a table with a tag or an owner. You need to kind of understand, hey, you need to do a patch. In some cases, I want to do put. So you kind of understanding the REST API or the nomenclature, not necessarily purely an SDK person. So that's what we want to solve. So we want to kind of take away the underlying details of REST APIs and give you much more easy to use. What we have developed here is Java, a Fluent-like API. And if you're familiar with Java, there is Fluent API, which chains operations and makes it really easy for the users, for the developers to use the metadata. So let me showcase some examples of that. I'm going to share my editor as well so that we can have a side-by-side. All right. Hopefully you can see both my screens, both my windows rather.
Yes.
All right, so let me go and show what we used to have. This is our example of Java SDK. I'm going to showcase, for example, how do you build a client? How do you get columns? These are all kind of related to, if you're familiar with any of the OpenMetadata, these are all our requests written in JSON schema, kind of translated into Java. This is our generated code that you're using directly, right? But where we want to get to, this is great, this is awesome, but where we want to get to, make it really, really easy, really understanding how we structure the APIs. So now on my right side, you can see in my IntelliJ a code. So what you need is your server URL, your token, could be your bot token, could be your personal access token. Just within 2 lines, you'll be able to kind of connect to that and create a client. And out of that, I'm going to go and create, using builders, how do I create a database service? A simple name, host port, username, password, without a verbosity of the previous JSON schema generated APIs. We came into really simple ones. From here onwards, all I need to do is, once I create the build, I need to call create. That creates my database service. And then database schema, finally a table, right? Uh, just do the builder pattern, I'll call the create, and that's it. Now, previously when we do, that's great, creation is simple. When we do updates, often you want to kind of fetch all your tables. Maybe you want to kind of take a look at some of the data inside the tables and apply certain tags, ownership, other properties that you want to do, right? That used to be a little more kind of confusing from a user's point of view. Hey, when do I use post versus when do I use to patch? So we take away all of that guessing work for you, and we make it really simple. So it's an existing table. Within a single line, I was able to call the client tables get by name using my fully qualified name and update the description and also add a tag and just call save. That's all you need to do. You don't need to worry about, hey, is it doing a patch? Is it doing a post? Is it doing, what are the HTTP methods that you need to do? I want to showcase some more interesting things like, glossaries, for example. One of the commonly asked things, hey, how do I export my glossaries? I want to import my glossaries. I have it in my CSV file. I want to do automatically through my CI/CD to update it. So all of that becomes now easy, right? So you just call the glossaries. You want to import CSV and just call the glossary name. It will import. You also have a dry run and everything else and execute. And also, even cooler thing here is we added async APIs for import and export because our users are importing tens of thousands of assets at one time. It takes time. Your load balancer may be having a shorter time span that may time out. So we built an async API in the REST itself. You send the payload, it will update it and notify through a WebSocket once it's done. And you see this in UI today itself. Now, how do I do that in the API in itself? So you can actually do an export CSV, listen for a WebSocket, and on complete, you can just display all of this data. Again, few lines instead of hundreds of lines coding this up with the new SDK. Let me run quickly, and so that you get a glimpse of it. So I have a local host running. So we are created an updated table. We did an exported glossary. We did an import. We also run an async. All this in a few lines of code, nicely organized to the current API. So this changes not only coming to the Java, but also to our Python. So similar to what we have shown here, similar kind of mechanism, really simple, really easy. Now I'm going to showcase what we used to do previously in our existing Python examples. For example, I want to update a description. So as a client or user of this API or SDK, I need to be able to fetch an entity. I need to make sure that it is decopied because we need to kind of create a new object. We need to set the description. Then we need to remember to make sure that it is a patch call and send both what is the entity type, what is the entity, the original entity, and the modified entity, so that it can actually internally do a JSON diff and supply it. From there, all the way to we did all this is I created a table and I'm updating description to this table start update. That's it. You don't need to worry about, hey, do I need to patch? Do you need to copy? Do you need to deep copy? All of the essential inner details of the work is abstracted away and made you much more easier to kind of deploy this. Few more examples. We just talked about list, creation and everything else. There are more things like this, right? I want to find by name, table start find by name. You don't need to, again, really simple API. I want to find the table. I want to include owners, include tags, and all the other fields that I want to fetch. By default, we don't give you all the fields, but I want to get, for this tables, I want to get domains. I want to get my owners. I only want those fields. It will come really nicely. Think, yeah, and similar to here, like I'm able to kind of delete and confirm. This is again an ability to not just call the delete, but saying that, hey, yes to delete kind of things, all nicely chained. Gives really easy, we believe will help you kind of get to shipping your metadata, reading your metadata really simple. I hope you will be able to use this API really well and give us feedback. This will be shipping along with our 1.10 release. Think I'm going to jump into quickly into other features that we are shipping. All right, so Lineage improvements we're going to show today is impact analysis. These are existing 1.9.10 release, I guess 1.9.10 rather. So in this release, in the previous release as well, you always had an option to export the lineage details into CSV for any impact analysis that you want to do offline. So what is impact analysis? I'm sitting in customers table. I want to change my schema. I want to change certain details. Will that impact any of my downstream users? Will I break any pipelines downstream? Will I break any dashboards? So that's where the lineage at its best for you to give all of these details. You already have a really nice visualization to kind of, hey, I want to look at customer ID, how it's flowing. If I change customer underscore ID name to something else, will that impact anyone else? The answer is simple. Here it's new view. But often the case that you need to give this data to someone else, you want to do offline, you have a nice way of exporting this lineage as a CSV or also an image. What we are going about here in upcoming release is you also have impact analysis right here in the product itself. You can see a nice table format with all the details of what is a downstream. I have 50 downstream and 50 upstream. What level is this particular nodes are there? What is the node depth? Who are the owners, if there are owners? Who are the tiers and tags? Not only that, these are the table level, these are the asset level, but I'm more interested in column level. So I can actually select column level and see again the same thing that I'm looking at, which columns are connected. Even though I have 50 downstream, maybe they are not actually reading all of my columns. Exactly, I'm looking at column 0, who it impacts if I change it. So you get very fine-tuned details right here. Then you can also search based on, I don't want all of this data, I want to look at specific assets, specific columns. You can also filter by the search right here. And as always, you can also download this data for, again, sharing with your colleagues or whatnot for offline analysis. All of this is right here and in upcoming release. I'm going to jump quickly into, I think, in the spirit of what Antonio was saying, hey, OpenMeta was really simple to get to up and running. We want to be, that's our foundation principle, right? So how do we make it's really easy for data teams to get it up and running, get the mileage out of it, get the value out of it. One of the questions that we get often in our support classes, we have extensive documentation is, they start with basic authentication. Hey, my team uses Okta, my company uses Google. How do I enable SSO? So if you go to the docs, enable security, there's huge amount of documentation written for it. But we also want to make it easy, right? So how do I actually turn this on even easier than what it is? We introduced SSO directly in the UI, in the settings. You can go to SSO here. Actually, let me go to my local host. It'll be easier. Settings, SSO. So you can get all this. I'm in my local host with the basic authentication. From basic authentication, I can move on to any of these providers that I have. Right? We have pretty much every SSO covered. Custom OIDC covers everything else. On top of that, we cover all the popular SSOs. So if I want to go to Google, I can just go click on configure. I get all of these details through to our form, documentation inline. You need to go to any different places to figure out. All of these details are nicely directed here. You should be able to kind of get up and running and save it. Once you save, restart your server. Now from basic authentication, you turn into Google SSO. I can go on and on. There are a lot more interesting features, but I want to be mindful of time and give them some time to talk about another new feature. Before my jumps in, I want to kind of give context to it, right? So our goal always has been extract the metadata wherever it is, right? It could be in your APIs, it could be in your databases, in your ML models, it could be maybe you're storing in your search indexes like Elastic or OpenSearch. We are also adding drives because we realize that metadata could be in your files, maybe you're storing in CSV. We often get questions like, hey, my business users are using this Google Sheets to build amazing dashboards. Can we get that metadata? So that's our answer. That's a feature that we are shipping right now. I think Maya is going to go talk about more in details.
Sure.